morning to all. Today we discuss about the topic is graph traversal. Okay, everybody knows what is meant by graph. Graph is a non-linear data structure. It considers the multiple edges and nodes. Okay, graph traversal is our main topic. It defined as a traversal. Traversal means that traveling from one location to another location, one node to another node. In graph, consider multiple edges or nodes. These all nodes visited once time. It can be used technique is the traversal. This traversal technique can be used to visit all the nodes in graph. Okay, this graph traversal technique can be categorized into two mechanisms. First of all, DFS and second one is BFS. The definition of the BFS and DFS is that DFS means that depth first search, and the second one is a BFS is the breadth first search. Then first of all, DFS, depth first search. This algorithm can be used to visit all the nodes once time in traversal method. Okay, first of all, DFS is defined. I already explained that DFS is depth first. This is same as the processing. Then first of all is the deeply move all the nodes. A depthward motion is the known as a DFS, depthward motion. Depthward motion is that deeply going to the all nodes of the graph. Then first of all, explain it. The graph traversal DFS method, DFS technique, DFS mechanism can be considered. Basically, from one node is the current node or root node. First of all, we select one node, root node or current node. These nodes consider several adjacency nodes, neighbor node. These nodes to main current node to and root node to directly connected to the adjacency node. Anyway, one or more nodes. These nodes can be connected to all the neighbor nodes of that current node. Neighbor node means the adjacency vertices or adjacency nodes of that current node. Well, once of all, this current node is connected to the neighbor node or adjacency node. Then next current node is that neighbor node. Then that neighbor node is another current node. That current node connected to another neighbor or adjacency vertices. These consider one or more nodes. In any case, one node can be chosen to next neighbor. Then connected to the another node, that is another current node. This is the traversing method of the DFS. It can be going to the all the nodes of the graph once. Any case, the dead end in one node, that time backtracking method can be used to reversely going to the another node, then that current node to connect to the another neighbor node. That completely visited all the unvisited or non-visited nodes, then visited all the nodes. Then this is a DFS method. This method can be used to visit all the nodes of the graph once time. Then backtracking method can be used to the dead end time and visit all the nodes of the graph once. In another method in graph traversal technique is the BFS. Also, I explained the DFS. Once point in remembering, the DFS method can be used in the stack data structure. That method pattern can be used in DFS. And now the BFS, breadth first search. This searching method or this traversal technique can be used in the queue data structure. This is a breadth word motion. Then going to the each node with all the adjacent vertices completely visited after going to the next neighbor node. That is the main difference between DFS and BFS. Then first of all, BFS, breadth first search. I am also said that the breadth word motion. Then first main important point of the BFS is the first root node or current node first of all select. Then that node consider multiple adjacency vertices. These all vertices, all nodes must visited after then going to the all the another neighbor node of the graph. It is the main difference in the DFS and BFS. Consider A is the our root node. A is connected a multiple one or more, two or more neighbor nodes in or adjacency vertices. These all nodes are visited after going to the another neighbor node. That is the main function of the BFS. In some cases in the backtracking method can be same as used in DFS. That is in used in BFS like a some dead end point. Dead end point means the last end point in node. That time we apply the backtracking method. This backtracking method can be used to reversely come to the current node. Then current node contains some adjacency unvisited nodes. That nodes is say visited after complete the our BF. This is the working of two traversal mechanism. I mean DFS and VFS working. Okay, now let's discuss about the example of the traversal and DFS and BFS. Okay, just to focus. Once again, I explained it the same topic, graph traversal. First of all, what is graph? I am also explain what is mean by graph. Graph is a non-linear data set. It consists of edges and nodes. Okay, everybody knows a graph consists of data set and it contains edges and nodes. Normal graphs can be categorized into two based on the direction of nodes or path of nodes. And the path of nodes of graph can be based to categorize the two level. First one is undirectional and second one is directional. The undirectional is no direction between nodes. Now I am also explain it. The graph contains multiple nodes. Each nodes are individually connected to another node. This undirectional graph considers no direction path between one node to another node. Already connected between two nodes, but no direction path. But directional level is and directional category consider each nodes in graph is connected in between direction level. The each nodes one nodes to another nodes direction path is available in directional graph. Okay. Now we discussed about what is a graph traversal. I am also estimating graph traversal. Traversal means that traveling or moving between one node to another node to visit all the nodes of the graph. One node to another node. I am also explained that. I am also tell us that one node to another node, one city to another city. The one node to another node is moving from to all the nodes of the graph. This is traversal method can be used. This graph traversal may be defined as visit all the nodes of the graph at one step. Okay, some traversal mechanism criteria traversal can be used to find the order of research and traversal process. These traversal processes can be used to find the order of all vertices in traversal order, and it applied to visit all the nodes of the graph. This traversal method can be used to apply and visit all the nodes of the graph. And then another application is the traversal method is find the shortest path between two vertices. The graph contains multiple vertices. The two vertices path, shortest path is found by using traversal and detecting cycling in graph. Any case multiple cycling available in graph. Large graph consider multiple nodes are available to form a cycling. That cycling can be detecting use. Okay. Okay, then go into next slide. Graph traversal technique. Also explain two mechanism, that is the DFS and BFS. DFS is a depth first search and second one is a breadth first search. First of all, then explain DFS, depth first search. It is used in a stack data set. I am also tell us it can be applied to visit all the nodes graph without using a looping. Another looping method not used. Visit all the nodes of the graph without using looping. Use the depth word motion. Depthly going to all the nodes at a visit once time and visit unvisited nodes of a current node and visit all the nodes at a current node to a neighbor node. Okay, some examples in here structure A, B, C, D, E. It is a graph. This graph contains multiple nodes. A is a node, B is a node, C is a node, D is a node, E is a node. This A is the current node, consider current node. This contains multiple adjacency vertices. Like A is a current node, it contains adjacency vertices B, it contains adjacency vertices C. Okay, next working is just checking. Okay, about the graph consider A, B, C, D. Okay, this graph consider no root node. I am also said that this contains no root node, and just first of all choosing the one letter is a root node. First we choose a root node is current node. A is the root node of the current node. This A is the root node or current node. Then A is the adjacency vertices B and C. This structure check. First of all, A is the current node or root node. This adjacency matrix is B and C. This is A is the adjacency vertices B and C. Next vertices C. Okay, first of all, I am choosing A is the current node and adjacency vertices B and C. Then next, I choosing C is the A is the nearest neighbor node C and B and adjacency vertices B and C. Then I choosing the next current node is C. Then go into C is the next node or current node. C contain a neighbor node is D. Only neighbor node is D and A. And A is also visited and not considered. And D is the not visited and considered. And D is the next current node. Next current node. Okay, D and A, C is the path. And then another section is the D. D is the another current node or root node. It contain a B, E, C are the adjacency nodes of the D. And directly D choosing the next neighbor node is D choosing the next neighbor node is B. Okay, then choosing B is the next current node and B choosing then B is another current node. This B consider A is the adjacency vertices and B is the adjacency vertices and D is the adjacency vertices. Okay, then next is the B consider a current node. B consider a current node. It consists EDA. EDA is the adjacency vertices. A and D is already visited node. That node that do to not consider, and E is the next last node. Then choosing E is the last current node. That is the path of this DFS algorithm. A C D B E. A C D B E. Then this DFS method can be used to visit all the node. A visit, then C visit, then D visit, then B visit, then E visit. This is a complete DFS algorithm applied. Okay. This method can be applied to last path is A, C, D, B. Any node can be visited, that time we using backtracking method. Any node can be visited, that time we using backtracking method. Any case, another node in this section that can be used to backtracking method. Any another node in B, any another node in D, that time E is the dead end. That time E is in the backtracking method can be used to return to coming to this B node and visit the another non-visit node. Okay, this is a DFS method. The next is the another breadth first search algorithm, BFS. This is a traversal breadth wide motion. This is used in a queue data searcher. The another algorithm is another technique is the BFS. It is used in a queue data searcher. Compare with the DFS, it is first time to visit all the adjacency node. I am also said that consider A is the root node. It contains C and B. Okay, these all nodes first time visit. This is the adjacency matrix is rule. The A is the root node and A contains multiple neighbor nodes, adjacency matrices B and C. This B and C already visited. This is the adjacency nodes of the current node by using backtracking method. Okay, so also said that a breadth first search. It is a BFS. It is a breadth wide motion. Compare with the DFS, it's the first time visit to all the adjacency node, our moving based. Okay, first of all, the example is example is the symbol graph A B C D E F. Okay, this consider a no current node or starting node. I am choosing first A is the current node and A is the starting node. The A consider a B and C are the two adjacency vertices. Okay, A consider B, C are the two adjacency vertices. I choosing B the next neighbor node. This is the current node. This current node consider another multiple vertices in adjacency. Like A is adjacency vertices because it is also already visited but not considered. And E is the next adjacency vertices. And D is the next adjacency vertices. And DE is the next adjacency vertices. Okay, A, D, E. Okay, we choosing A, D, E completely. B can be using a backtracking method. Backtracking method can be used to, and then first of all A, and the A is visiting to the C. This A, B, C is the first of all first visiting three nodes A, B, C, and then going to C. C is the next kernel node. This B node can be used backtracking method. Backtracking method can be used to visit the C, and C the next kernel node. C next kernel. C consider adjacency vertices are A and D. Okay, and then choosing next kernel node is a D. Okay, D is considered multiple vertices, adjacency vertices. First one B and E, then third one is C. And just choosing D is a next adjacency vertices E. E is a dead end that due to E backtracking method, then directly going back to D node, and D node is a next kernel node, and then going to the another neighbor node is F. That is A, B, C, D, E, F. It is the BFS breadth first search algorithm. It is the most used in several applications. Like it can be used to cycling. The repetition cycling in a graph can be found, and several applications can be used applied in the breadth first search. These are the two mechanism and two algorithm in a graph traversal. First one DFS and second one BFS. It's so easy to understand and simply to study, and good listen to practicing and workouting. Okay, thank you.